So good day class, today we are going to talk about the introduction to analytical chemistry together with its nature and its statistical applications. Analytical chemistry is a branch of chemistry that deals with the operation and analysis of chemical substance. So qualitative analysis denotes what is present in the sample. It determines the actual constituents present in the sample, while quantitative analysis denotes how much is present in the sample. It determines the amounts of constituent present in the sample. Analyte is the species and the sample about which the analytical information is sought. So, doon sa mga previous lessons natin, meron tayong mga nabanggit na analyte. So, ano nga ba yung analyte? So, yun yung component ng sample na meron kang gustong malaman. Here are the classification of analysis. First, based on the extent of analysis, we have complete or exact analysis, wherein the amount of each constituent is determined quantitatively. For example, sa blood analysis, dinadetermine yung glucose, amount ng sodium, potassium, and bilirubin. So we have ultimate analysis, wherein the amount of each element is being determined. Kunwari, sa gasolina, so ilang percent ba doon yung carbon, yung hydrogen, oxygen, and yung lead, which is important kasi we have leaded and unleaded gasoline. And lastly, we have proximate or partial analysis, wherein the amount of a certain or selected constituent in a sample is determined. For example, sa aspirin tablet, percentage ng salicylic acid, or sa biogesic, how many paracetamol is present on the sample. Next, we have the classification based on the size of sample available for analysis. If you have greater than 100 milligrams or 100 microliters, we call that a macro analysis. If you have approximately 10 to 100 milligrams or 50 to 100 microliters, we call that semi-micro. And for the microanalysis naman, if you have 1 to 10 milligrams or less than 50 microliter, rather, na volume of sample, we call that microanalysis, and ultra-micro naman yung less than 1 milligram. So next classification is based on the amount of analyte in the sample. So if you have greater than 1% of the amount of the analyte in the sample, we call that major constituent. So if you have 0.01 to 1%, that is called minor constituent, and 0.001 to 0.01%, that is called trace constituent, and less than 0.001% is called ultra trace constituent. The last classification of analysis naman is based on the method of analysis. We have the classical method, which is gravimetric. So we have an experiment about that, wherein the mass is being involved, and volumetric naman sa volume. We have instrumental, we have electroanalytical, or for the testing of current or voltage, spectroscopic for radiation, and chromatographic for the separation. I know that I have tackled this in our previous lesson in the introduction to qualitative analysis, but I have to repeat this because this is an analytical chemistry class. So these are the general steps in analysis. So first is to select the method of analysis. So it should be cost and efficiency of the method must be considered. Next is the sampling. It differs with different samples. So, di ba, sinabi ko na kapag solid, liquid, or gas, different yung treatment or preparation ng sample. Next is the conversion of analyte into a form of suitable for measurement. So it involves the moisture determination, dissolution, and elimination of interference. Next is the measurement of the property of the analyte. And then finally, the calculation and the interpretation of data. So in doing a laboratory analysis, accuracy and precision of the test is really important. So accuracy is the closeness of an experimental value to the true or accepted value. And precision is the closeness of experimental values with each other obtained in the same manner. So ano bang ibig sabihin nun? As you can see in the slide here, the dart here or yung pagkakathrow ng dart, this denotes low accuracy and low precision kasi low precision and low accuracy. So, kung accurate siya, dapat malapit siya sa bullseye. And then, low precision kasi magkakalayo yung nakuha niyang result or yung pagkakabato niya sa dart. And then, now we have here low accuracy but high precision. So, magkakalapit yung nakuha niya, pero mali yung nakuha niya na result. So, magkakalapit nga yung nakuha niya na result, pero mali naman yung analysis result niya. So, next image is we have high accuracy but low precision. So, malapit na siya dun sa bullseye compared dito sa mga naunang image, pero magkakalayo naman yung nakuha niya na result. So, here, the last image, we have high accuracy and high precision. So, lahat dapat ng laboratory analysis na gagawin natin is high accuracy and has high accuracy and has high precision. So, as you can see here, lahat sila malapit sa bullseye and magkakalapit yung nakuha niya. Next is we have errors in analysis. So what is error? So error is the difference between an experimental measurement and its accepted value. So absolute error is an accuracy measurement equal to the numerical difference between an experimental measurement and its true value. So absolute error is experimental value minus the true value. So, relative error naman is the absolute error divided by the true value. It may be expressed in percentage, PPT, or ppm. So, here's the formula for the relative error. So, next is we have the types of error in the data. First, we have the random or indeterminate errors. So, it's uncertainties resulting from the operation of small uncontrolled variables that are inevitable as measurement systems are extended to and beyond their limits. So, this random error, hindi mo alam kung saan siya nanggaling, and it's inevitable, so ibig sabihin hindi mo siya mapipigilan. So, pwedeng lumabas na siya sa detection limit or hindi na kaya ng instrument mo yung gusto mong gawin, kaya nagkaroon ka ng random error. So, random error affects the precision of the result. So next we have systematic or determinate errors, wherein it has a known source and they can affect measurements in one and only one way and can in principle be accounted for. So for example, yung ginamit mo na analytical balance for weighing your sample is luma na and may kalawang na sa loob. So ang mangyayari is yung measurement mo is hindi na accurate. So as you can see here, systematic errors affects the accuracy and it leads to bias. So what is bias? Bias measures the systematic errors associated with an analysis. So next we have the type of systematic errors. First is the instrument error. It may be caused by temperature changes, current fluctuations, and calibration must be performed to avoid this type of error. So, nakalagay naman doon sa mga gamit natin and glasswares na for example at ganitong temperature, at room temperature, or at 25 degrees Celsius, ganito yung 100 ml siya. So, Kapag nagbago yung temperature, hindi na siya ganun ka-accurate. So, that is what we call instrument error. Next is method error. It may be introduced by non-ideal chemical or physical behavior of reagents and reactions upon which an analysis is based, and it is often difficult to detect. For example, contaminants. So, for example, yung sample na winnie mo sa gravimetric analysis mo is nagkaroon, for example, humangin, nagkaroon ng mga alikabok. So, contaminant na yung tawag doon. Next is yung personal error, and it arises from personal judgments, prejudice, or number of bias. For example, failure to judge properly the endpoint of titration. So, for example, kukulusan kayo sa lab, tapos nakalimutan na sobrahan yung dagdag nyo, so na-miss nyo na yung endpoint. Or for example, mali yung tingin mo dun sa glassware na dapat yung pipette pala hanggang 10 ml mark lang, pero inubos mo yung nandoon sa loob ng pipette. So, that is called personal error. Here are the steps on detection of systematic error. So first, analysis of standard reference material. So I believe we have discussed it on our previous lessons. And a second, independent and reliable analytical method can be used in parallel with the method being evaluated. So for example, meron kang bagong method na gustong gawin or subukan, or dahil magaling ka na, matagal ka na dun sa lab na ginagawa mo, feeling mo meron kang shortcut na pwedeng gawin dun sa standard na ginagawa niyong method. So, bago siya maging okay sa lab or gamitin sa lab, you have to evaluate and approve that method. So, paano yun ginagawa? You have to try the new method that you are going to use, and then isasabay mo siya dun sa standard method or existing method na ginagawa niyo na sa lab, and then kapag same yung result na nakuha mo, ibig sabihin okay yung naisip mo na method. So that is how we evaluate a method. Next is blank determination. So ano ba yung blank? So during analysis, meron tayong tinatawag na positive or negative control. So, yung blank determination, yun yung negative control, wherein, for example, gusto mong mag-test ng kung gaano karaming paracetamol ang meron sa biogesic. So, isasabay mo yung isang sample na walang laman na kahit ilan, as in none at all, paracetamol, tapos i-compare mo siya dun sa merong paracetamol. So, ibig sabihin babawasan yung error na pwedeng mag-arise kasi meron kang sinabay na sample sa kanya na walang laman, and then versus dun sa gusto mong i-test na sample. So, lastly is varying the sample size. So, pwedeng kumuha ka dun sa mas malaking sample. Di ba meron tayong diniscuss na merong hinahati yung sample? Like, pwede kang kumuha dun sa kinwarter and cone mo, hinati mo siya ng dalawa. Pwede kang kumuha dun sa mas malaki, and then dun sa mas maliit, and then compare the analysis. And lastly, we have the gross error. It is an occasional error and neither random nor systematic, that the result in the occurrence of a questionable outlier result. For example, spilling of a portion of sample during transferring of liquid to container. So, for example, nagpa-pipette ka, tapos natumba ka, and then may natapon dun sa sample na tina-transfer mo. That is what we call gross error. Here are the statistical tools that are being used in an analysis. First, we have the analysis that measures the central tendency, which are mean and median, followed by the measure of variation or precision. We have spread or range, standard deviation, variance, relative standard deviation or RSD, and coefficient of variation CV. We also have analysis measures of accuracy, which are absolute and relative error. Next, we have Q-test for gross error detection, LSM or least square method. I believe we have tackled this on a few slides ago or the previous lessons we had. We have calibration method, also this, external calibration and internal standard calibration. So, what is mean? Mean is the average value of two or more measurements. So, here's the formula. So, it means na yung summation, here denotes the summation of everything divided by kung ilan sila, the number. For example, you have 1, 2, 3, 4, 5. So, kapag in-add mo sila lahat is 3 plus 3, 6 plus 9, 15 divided by 1, 2, 3, 4, 5, 5. So, ang mean mo is 3. Next, we have median. It is the middle value in a given set of data that has been arranged in order of size. So, katulad ng example kanina, 1, 2, 3, 4, 5. So, ang median natin dyan is yung 3 kasi siya yung nasa gitna kapag in-arrange mo sila in order of size. So, next we have the spread or range. So, it is denoted as the W and its formula is the largest value minus the smallest value. So, sa example natin kanina na 1, 2, 3, 4, 5, para makuha yung range, we have to minus the largest value, which is 5, minus 1, the smallest value, and your range is 4. So, next we have the standard deviation. So, to compute the standard deviation, here's the formula. So, ito yung number. For example, sa 1, 2, 3, 4, 5, ito yung 1, 2, 3, 4, 5. Tapos, ito, x, ito yung na-compute natin kanina na mean, squared, square root nun, ng lahat ng yon over n minus 1. So, papakita ko sa inyo kung paano siya ginagawa. So, we have 1 minus, ano yung nakuha nating mean kanina? 3, right? Over n minus 1. So, n, ilan sila? 1, 2, 3, 4, 5. So, you have 5 minus 1. So, square root ng lahat ng yon. So, here, kinompute ko na yung standard deviation. So, 1 minus 3 squared is 2 squared plus 2 minus 3 squared is 1 squared plus 0 squared is 0. Plus 4 minus 3 squared is 1 squared and 5 minus 3 squared is 2 squared. So, equate lang and you'll get 1.5. So, yun na yung standard deviation. So, yung variance naman is S squared. So, kung ano yung nakuha mo sa standard deviation kanina, is squared mo lang siya. So, it's 2.5. So, bakit nawala yung square root? Kasi kapag in-square mo na yung buong equation, mawawala na yung square root. So, ito na lang yung formula ng variance, or it is S squared. So, next we have the coefficient of variation. So, this is just the standard deviation over the mean. So, sa example natin kanina na 1, 2, 3, 4, 5, so standard deviation is 1.58 over 3 times 100%. So, you'll have 52.67%. So, RSD naman, or relative standard deviation, this is also the SD, or the standard deviation, and the mean. So, just 1.58 over 3 times 1,000 ppt, or parts per thousand. So, this is 526.7 ppt. And then we have the measures of accuracy. First, we have the absolute error. So, absolute error is equals to the observed or experimental value or obtained value minus the true value. Next, we have the relative error, wherein this is also the observed value. And this is the true value divided by the true value times 100%. So next, we have the first question na ilalagay nyo naman sa inyong learning log. So, lead is considered as toxic heavy metal for human because it can cause nervous damage, especially to children. The following results were obtained in the replicate analysis of a blood sample for its lead content using AAS as the method. So these are the data obtained. Calculate the mean, median, range, standard deviation, variance, coefficient of variance, and relative standard deviation if the accepted value is 0.755 ppm or parts per million lead. Compute for the absolute error and relative error. So next we have the Q-test. It decides for a suspected value or outlier, usually the lowest or the greatest value. So yung Q-test, ginagamit niya siya kapag, for example, meron kang set of data or sa experiment mo, sa tingin mo yung isang result mo is sobrang mababa or sobrang mataas, iniisip mo na baka nagkamali ka doon, may error yung nagawa mo, kaya subject mo siya sa Q-test para malaman mo kung accepted pa yung value na yun or pwede mo na siyang tanggalin. So, to compute for Q-test, find Q-crit for a specific confidence interval. So, may table tayo dyan sa next slide. And then, find for Q experiment. So, here's the formula. W is the range. XQ is the questionable result, yung na-obtain nyo, yung pinagdududahan yung resulta, and XN is yung nearest neighbor. So, paano malalaman yung xn? So, kailangan mo rin siya i-arrange ng lowest to highest, tas kung ano yung pinakamalapit niya. So, if Q experimental is greater than Q crit, the questionable result can be rejected with the indicated degree of confidence. So, here's the critical values for the rejection quotient. So, ito yung confidence level, kung gaano ka ba ka-confident doon. So, if Q experimental is greater than the Q critical, kailangan mong i-reject yung result na yon. So, okay, let's solve for this. 5 denominations of the vitamin C content of a citrus fruit drink using ideometric titration give the following results. Apply the Q-test to see if 0.230 value can be discarded at 90% confidence interval. So, binigay yung 90% confidence interval, doon mo daw titingnan. And then, yung sa tingin ng gumawa na to, yung questionable result or yung pinagdududahan niyang result or value is yung 0.230. So, to solve for Q-test, so N is 5. So, paano natin nalaman na 5 yung N? So, syempre, binilang natin kanina kung ilan yung given. And Q-crit, paano malalaman yung Q-crit? So, here, sa table ng critical values. And then, XQ, yung pinaghihinalaan mo or yung sa pinagdududahan mong resulta. And then, yung nearest neighbor, yung 0.220. Again, yung nearest neighbor is, malalaman mo kung kapag in-arrange mo siya from lowest value to highest value kung ano yung pinakamalapit niya na data. So, range formula is yung highest value minus the lowest value. So here, pasok nyo lang sa formula and yung nakuha nating Q experimental is 0.67. So, 0.67, is it higher or lower than 0.642? So, it is higher. So, since it's higher, we can say that Q experimental is greater than Q critical. Therefore, 0.230 value can be discarded. Or pwede nyo siyang tanggalin and we can say that it is an outlier. Next, we have the least square method. I remember na na-discuss na din natin to sa previous lesson natin. But I'll discuss this again. So, LSM or least square method, it is establishing a linear relationship between the measured variable y and the analyte concentration, which is x. So, remember yung linear line formula, y is equals mx plus p. Remember from your algebra. So, maybe solve using your calculators. Remember that A sa calcu nyo is equal to the y-intercept and B is the slope. Well, depende pa rin yun, pero in most calculators yun. So, r squared must be 0.999 or better to be considered as linear. So, calibration is the empirical determination of the relationship between a measured quantity and a known reference or standard value. It is also used to establish analytical signals versus the concentration relationships in a calibration or working curve. So, signal of analyte S is equals to the K times the C or the concentration of analyte. So, na-discuss ko na din to before and nagbigay na rin ako ng example. Next, we have the external standard calibration. It can be a single point or multiple point. Signal is proportional to the concentration established using externally prepared standard. So, yung standard mo, wala siya sa loob ng samples mo, kundi nakahiwalay or nasa external. It assumes that the sensitivity is the same for samples and standards. It also assumes that the signal arises only from the analyte in most cases. It does not account for sample matrix or instrumental drift. So, ang ibig sabihin nito, for real-life situation, katulad pa rin ng dati nating example, for example, sa paracetamol, sa biogesic. So, yung gusto mong i-test is yung concentration ng paracetamol doon sa biogesic. So, yung sample mo, yung mismong tablets or yung mismong gamot, and then, meron kang standard na nakahiwalay na alam mo talaga na paracetamol yon and i-compare mo sila. For single point calibration, a standardization technique where only one standard solution of known analyte concentration is used. Signal response is directly proportional to the concentration of analyte. Least desirable way to standardize a method because all of the experimental errors, both determinate and indeterminate, are carried over into the calculation value of K. So, ito yung least desirable kasi mas prone siya sa determinate and indeterminate errors. Okay, let's answer this sample problem. A chromatographic analysis of trihalomethanes in drinking water gave a peak area of 1.56 times 10 to the 4th for chloroform. A 1.30 ppm chloroform standard gave a peak area of 1.35 times 10 to the 4th. Calculate the concentration of chloroform in drinking water. So, sabi natin kanina, ang formula is signal is equals to the K times C, which is the concentration. So, K is constant. So, para hindi kayo malito ulit, isulat nyo muna kung ano yung given or kung ano yung meron. So, ang hinahanap natin is yung concentration ng sample, pero nabigyan ka ng concentration ng standard, peak ng sample, and peak ng standard. So, ayan na yung derivation. So, peak is yung signal. Kasi kapag sa instrument, yung peak, yan yung signal na binibigay ng instrument is usually peak or value. So, ayan, yung value nun, yun yung signal. So, sige, i-derive natin. So, yung signal is yung P is equals to D K over concentration. So, if gusto nyo is yung standard, so STD, so since constant is parehas lang yon, so it is equal to this formula. Okay? Same lang, diba? So, since concentration ng sample yung hinahanap, derive mo lang yung sa formula, and then you'll get this. And then, palitan nyo lang yung value. So, ito na yung peak ng sample times concentration ng standard divided by the peak of standard. So, you have 1.50 ppm. So, again, ito yung least desired method kasi prone siya sa errors. Pero ito yung pinakamadaling i-calculate sa lahat. Next, we have multiple point standardization, a standardization technique that uses 3 or more standard solutions containing a known amount of analyte. Calibration curves are usually constructed by analyzing a series of external standards and plotting the detector signal as a function of their own concentration. As long as the injection volume is identical for every standard and the sample, calibration curves prepared in this fashion give both accurate and precise results. So, this is better than the single point standardization. So, I believe ito yung example na pinakita ko nung isa. Okay, I believe na ito yung binigay kong example sa inyo nung previous lesson. It's an example of multiple point external standard calibration. So, okay, let's answer this problem. A multiple point calibration curve was plotted for the analysis of chlorpyrifos, and the following were the results. A sample was analyzed which gave a peak area equal to this one. Calculate the concentration of chlorpyrifos in the sample. So, ito yung na-obtain na calibration curve dun sa data na binigay. So, no previous lesson, pinakita ko na rin sa inyo kung paano siya ginagawa sa Excel and kung paano siya pinaplot. So, actually, pwede nyo yung magawa sa mga calculators nyo. So, paalala nyo sa akin na ituturo ko sa inyo yung shortcut kapag nag-synchronous class tayo na kung paano nyo siya magagawa sa mga calculators nyo. So, here, ito yung solution from the equation of the line. Y is equals to M, ito yung M, X plus B. So, ito yung B mo. Calculate the value of X kasi yun yung concentration mo, where Y is equal to the peak of area of sample. Okay? So, X is equal to the Y plus Y-intercept over the slope. So, X is equals to 3597765 plus 57066 divided by yung slope here is 1 times 10 to the 6. So, ito kanina, given to, ito yung binigay na data dun sa question. So, itong 57066, ito siya. Nakuha mo siya sa na-generate mo na equation of the line. And then, ito yung 1 times 10 to the 6. And then, kapag sinolve mo to, you'll get 3.65 ppm or parts per million. So, if kanina we have external standard calibration, we also have internal standard calibration naman ngayon. It is also known as relative or indirect calibration. In this approach, an internal standard is added to the sample. So, kanina external nakahiwalay yung standard, internal naman kasama ng mismong sample. Kaya siya internal nakahalo na sa loob. And the response from the analyte peak is compared to the internal standard. Unlike the external standardization, internal standard method accounts for variance in instruments' performance. It can also be single or multi-point. So, internal standard is a standard whose identity is different from the analyte. So, kung kanina, paracetamol yung gusto mong i-test, paracetamol din yung standard mo. Pero dito, the identity is different from the analyte. that is added to all the samples and standards containing the analyte. Response factor, or RF, accounts for differences in the detector's response between analyte and standard. So, since iba yung standard sa sample, meron kang response factor, yun yung difference nila. So, since iba yung standard mo sa samples mo, meron ka dapat requirements for an internal standard. Hindi, for example, gumana dito sa sample na to, yung standard na to, hindi ibig sabihin na gagana na din siya dun sa iba mong sample. So, we have a criteria on choosing what is the suitable internal standard. First, the internal standard must act similarly with the analyte or dun sa sample na tinitest. No interferences sa analyte and internal standard or sa sample matrix and sa internal standard. Also, internal standard must emulate drift and matrix effect behavior. Internal standard is not native in the sample. So, hindi siya din dapat nag-react dun sa internal standard. I mean, yung standard, hindi siya dapat nag-react dun sa analyte or dun sa sample. So, here's a sample chromatogram and integration point for analyte and internal standard. So, here's the sample or yung analyte and here's the internal standard. So, makikita nyo, walang interferences sa kanila. They gave separate peaks or different peaks, different area. Ayan, makikita nyo na hindi naman sila parehas. So, walang interference and okay yung internal standard and yung analyte. So, now we have the single point internal standard calibration. It requires at least two analyses. The first analysis contains a known amount of internal standard and a known amount of analyte. The response factor is then calculated. So, yung RF kanina, na pinakita ko din sa previous slide, ito din yan. So, formula is RF is equals to the response of internal standard times the concentration of analyte over concentration of internal standard times the response of the analyte. So, mapapansin nyo na parang parehas lang yung formula ng external at internal. Ang difference sa internal, meron kang response factor. Then, a known amount of internal standard is added to the sample containing an unknown amount of analyte. The amount of analyte in the sample can then be calculated. So, here's the formula. So, kita nyo, same lang siya ng external, pero you have the response factor being multiplied here. Okay, then let's answer together this sample problem. A solution containing 200 ppm toluene, an internal standard, and 100 ppm benzene, an analyte, was analyzed using gas chromatography. The resulting peak areas are 120,000 for toluene and 67,000 for benzene. A sample containing 200 ppm toluene and an unknown concentration of benzene was analyzed using the same chromatographic conditions. And the resulting peak areas are 122,000 for toluene and 43,000 for benzene. Calculate the concentration of benzene in the sample. So first, katulad ng lagi kong sinasabi, always nyong ilagay yung given para hindi kayo malito. And yung you have to calculate first the value of the response factor kasi hindi mo naman makakompute yung concentration ng benzene if unknown yung response factor. So, substitute, peak area ng internal standard is 120,000 times concentration of analyte, which is benzene, 100 ppm, times concentration of internal standard, 200 ppm, times 67,000 na area ng analyte. So you will obtain an RF value of 0.896. So now, with that, you can calculate the concentration of benzene by substituting here in the formula again, given kanina, 200 ppm concentration ng toluene, 43,000 peak area ng benzene. So, di ba kailangan natin ng two solutions, sabi kanina, as a criteria sa single point internal standard calibration. So, dito nyo na siya makakompute. And then, times the RF factor divided by 122,000 na peak area ng toluene. And then, you'll get 63.2 ppm. So, yun na yung concentration ng benzene nyo. Next, we have multiple point internal standard calibration. So, it uses several standard solutions containing a known amount of internal standard whose concentration is kept constant and analyte of interest whose concentration covers the range of concentrations expected. The ratio of the response of analyte to the response of internal standard is plotted against the concentration of analyte. Then the calibration curve generates an equation of the line which is then used to calculate the unknown amount of analyte in the sample. Okay, let's answer this all together. A sample containing an unknown amount of heptachlor was spiked. So, spiking yung tinatawag dun sa pagdagdag ng known concentration para makapasok siya dun sa detection limit na instrument. With the same amount of internal standard, and the analysis resulted to a peak area of 1334039 for anthracene and 144076 for heptachlor. Calculate the concentration of heptachlor in the sample. So, anthracene D10 is the internal standard. So, to answer the sample problem, you have first to calculate the ratio of peak area of analyte to peak area of internal standard for every standard solution. So, here. And then, after nyo ma-compute, you have to plot the peak area of internal standard against the concentration of the analyte katulad nito. So, again, may ma-generate ka ulit na R squared and equation of the line. Again, halos same lang siya ng computational process ng external standard calibration. Pero ang difference sa internal is meron kang RF. Then, the equation of the line is used to calculate for unknown concentration of analyte in the sample. So, na-generate natin na equation of the line kanina is this. And we know that Y is equal to the peak area of analyte over the peak area of internal standard, and X is the concentration of analyte. So, substitute sa formula, and then you'll get 39.9 ppm or parts per million heptachlor. So, yun na yung concentration na hinahanap. And that's all for the statistics and introduction to analytical chemistry. Thank you.